Good afternoon, everybody. I hope you had a nice weekend, and I hope that everybody's doing okay. We're going to be looking today at lesson 30.06, which is on page 15 of your lesson handout. And I am perfectly aware there is no 30.05 here. I just misnumbered things in your lesson handout. We're looking today at 4 new identities. They are called the sum and difference identities, and they are used to determine the sine or the cosine of the sum of 2 angles or the difference of 2 angles. So I'm not going to read through all of these. I do want to draw your attention to the fact that there is some kind of printing error. When I printed my document to PDF form, something got a little bit jumbled, and I didn't notice it before I gave it to you. The identity for the cosine of alpha minus beta should say cosine of alpha multiplied by cosine of beta plus sine of alpha multiplied by the sine of beta. When it printed to PDF, there was some weird symbol that got included in there where the plus sign should be. So I'm not going to go through each of these identities with you. They are on your formula sheet. If you were to look on your formula sheet, about halfway down the right-hand side, you'll see the sum and difference identities for sine and cosine. What you will also notice is that there are sum and difference identities for tangent. And I've decided that because we are a little bit crunched for time in trying to get through the course under these conditions, that I'm not going to worry about the tangent identities for sum and difference. Even if you're worried about going on next year to Math 31 or Calculus, where you're going to be using some of these identities, I think you can get by dealing with only the sine and the cosine identities for sum and difference. So let's take a look at some examples. And at least to begin with, the examples are going to involve you trying to match up some information in a question to an identity. And I just want to rewrite this question, 1a, a little bit bigger. Sine of 42 degrees multiplied by cosine of 19 degrees, and then minus the cosine of 42 degrees multiplied by the sine of 19 degrees. The whole idea here is you want to be able to take that question and compare it to your 4 identities. And when we take a look at the 4 identities, there is one of them that has this pattern of having a sine of an angle multiplied by the cosine of an angle minus the cosine of the first angle multiplied by the sine of the second angle. And you can see that pattern is right here. That the sine of alpha minus beta equals sine alpha cos beta minus cos alpha sine beta. So what we can do is basically do a comparison of that identity to the question. Sine of alpha cosine of beta minus cosine of alpha sine of beta. So you can see by comparison that alpha is 42 degrees and beta is 19 degrees. Just to highlight that for you, the 42 degrees is comparable to alpha, whereas the 19 degrees is comparable to beta. And we know that sine alpha cos beta minus cos alpha sine beta is equal to sine of alpha minus beta, which means that this expression is equal to sine of 42 degrees minus 19 degrees. And we can certainly simplify that. 42 minus 19 is 23. So question 1a is equivalent to writing sine of 23 degrees. Now I would like to show you what this identity actually means. If I go to the calculator, I can enter in, and I'd better make sure I am in degree mode, and I am, the original expression, which was sine of 42 degrees multiplied by cosine of 19 degrees, minus cosine of 42 degrees multiplied by sine of 19 degrees. And what the calculator returns is this number, 0.39073, and there's more decimals. On the other hand, we've said that according to this identity, this expression should be equal to sine of 23 degrees. And in fact, if we calculate the sine of 23 degrees, we get the exact same result. All right, let's take a look at question 1b. And this one is a little bit different because we don't see in this list of identities that I've given you today cosine squared minus cosine squared. But I can rewrite this as cosine of 2 pi over 3 multiplied by cosine of 2 pi over 3 minus sine of 2 pi over 3 times sine of 2 pi over 3. Because we've learned that when you see cosine squared, it means the cosine times the cosine. It means you're squaring the cosine. Now, we can now compare this to our identity list, and one of the identities is cosine alpha cosine beta minus sine alpha sine beta. And on your identity sheet, that's equal to cosine of alpha plus beta. This is just a little bit different than example 1a because when we do a comparison here, we can see that alpha is 2 pi over 3. And it turns out that beta also happens to be 2 pi over 3. So alpha and beta are both the same angles. But it doesn't change the fact that cos alpha cos beta minus sine alpha sine beta is equal to cosine of the sum of the two angles. So we can rewrite this original expression as cosine of alpha, which is 2 pi over 3, plus beta, which is 2 pi over 3. That gives us cosine of 4 pi over 3 as an answer. And since 4 pi over 3 happens to be one of those special angles on our unit circle, we could actually calculate what the exact value of cosine of 4 pi over 3 is equal to. We would go to the unit circle and we would locate 4 pi over 3, which is in quadrant 3. 4 pi over 3 is this location right here. And the cosine, of course, on the unit circle is equal to the x coordinate, which means that the answer is negative 1/2 if we wanted to actually come up with a value for the expression. It turns out in the question, I believe we were just asked to write it as a single trigonometric expression, so we don't have to calculate it, but this does happen to be equal to negative 1/2. Let's take a look now at example 2a. You're asked to simplify sine of pi minus theta. At first you look at this and you kind of wonder, well, how can you simplify that? The answer is going to be that you're going to use an identity. You're going to use an identity that matches that. So we do have an identity for sine of an angle minus an angle. It's equal to sine of the first angle multiplied by cosine of the second minus cosine of the first angle multiplied by sine of the second. In other words, we're comparing here alpha to being pi in our question and beta to being theta, and we're going to put those into this identity, which means we're going to have sine of pi minus theta is equal to sine of pi, cos of theta, minus cos of pi, sine of theta. Now, sine of pi and cosine of pi are things we can calculate because those are also special angles on the unit circle. If I were to take a look at pi on the unit circle, which is down here, the coordinates of a rotation angle of pi are -1, 0. Now don't forget, again, on the unit circle, the x-coordinate is the cosine of that rotation angle, and the y-coordinate is the sine of that rotation angle. In other words, the cosine of pi is -1, and the sine of pi is 0. So if we go back to our question then, we can start putting in those values. Again, sine of pi is something that we can calculate on the unit circle, and it happens to be equal to 0, the y-coordinate at pi, multiplied by cosine of theta, and then minus cosine of pi on the unit circle is the x-coordinate, which we know is -1, multiplied by sine of theta. So a couple of things happen here to give us our answer. Sine of pi minus theta is equal to 0 plus sine of theta, which means sine of pi minus theta is equal to sine of theta. The negative times the negative becomes a positive, and then of course 0 multiplied by the cosine theta is 0. So the answer to this question is sine of pi minus theta is equal to sine of theta. And you could check this out on your calculator. You could take, and I'm not going to do this, but you could take sine of pi minus 1.3 rads and calculate it, and then you could just take sine of 1.3 rads, and what you would discover is you get the exact same thing. Let's take a look at example 2b. We want the cosine of x plus 180. Well, 180 degrees is that same location we were just looking at, which is pi, so that will be useful in a second. For the sum identity for cosine, when you look at your formula sheet, you will have cosine of the first angle, cosine of the second angle, plus, my mistake, minus sine of the first angle, sine of the second angle. And now we're going to do the same thing we did in the previous question. Cosine of 180 degrees is -1. Sine of 180 degrees is 0. So we end up with cosine of x times -1 minus sine of x multiplied by 0. Sine of x multiplied by 0 is simply 0. So we're left with cosine of x times -1, which is negative cosine of x. This is our answer. All right, question 3 says find the exact value of the cosine of 105 degrees. Now, as soon as you're looking at an exact value, you need to be able to go to your unit circle. The problem here is, although 105 degrees is on the unit circle, every angle can be found on the unit circle. Although 105 degrees is on the unit circle, it's not one of those special angles that we have knowledge of in terms of the x and y coordinates. So it appears as though we can't just look at the unit circle. But what we can do is recognize that 105 degrees is a sum of two angles that we do have information of regarding the coordinates. 45 degrees plus 60 degrees gives us 105 degrees. And 45 degrees is a point on the unit circle that we know the x and y coordinate of, and so is 60 degrees. So instead of calculating cos of 105, what we can do is say we're going to find the cosine of 45 degrees plus 60 degrees, and we're going to apply an identity to that. The identity for cosine of a sum of two angles is you take the cosine times the cosine and subtract the sine times the sine. So I'm going to be using this identity. So we have cosine of 45 degrees, cosine of 60 degrees, minus sine of 45 degrees, sine of 60 degrees. And you should have your unit circle handy while you're watching this video. However, I'll just show you the coordinates for those points. In quadrant 1, 45 degrees is here, and 60 degrees is here. And remember that the x coordinate gives you the cosine of a particular angle, and the y coordinate gives you the sine. So going back to this question, cosine of 45 degrees is root 2 over 2. I'm going to choose to use the root 2 over 2 version. I know that up here I have root 2 over 2, but on your unit circle you may have written in 1 over root 2. They're the same numbers. And then I have to multiply by the cosine of 60 degrees. The cosine of 60 degrees is 1/2. Minus the sine of 45 degrees is the y coordinate, my mistake, at 45 degrees, multiplied by the sine of 60, which is the y coordinate at 60, which is root 3 over 2. So we're multiplying fractions here. Root 2 over 2 multiplied by 1/2. We multiply across the top, and we multiply across the bottom to get root 2 over 4. Minus, the same thing goes here. We multiply across the bottom. And when you multiply across the top, root 2 multiplied by root 3 is root 6. We've got a common denominator, so the answer to this question is that the exact value of cos of 105 degrees is equal to root 2 minus root 6 all over 4. Just to convince you of that, I'll just double check I'm in degree mode. If I take the cosine of 105 degrees, I get this number. If I take the square root of 2, subtract the square root of 6, and then divide that result by 4, I get the exact same number. So the cosine of 105 degrees is root 2 minus root 6 all over 4. All right, and that leaves us with one more example to go. Question 4. You're told two pieces of information. The first one is that you have an angle that is in quadrant 4, and the cosine of this rotation angle has a value of 5 over 13. You have another angle, angle B, which is in quadrant 3, and the tangent of angle B is 4 over 3. You're asked to determine the exact value of the sine of A plus B. Well, we know from our identity that the sine of angle A plus angle B will be equal to the sine of angle A multiplied by the cosine of angle B plus the cosine of angle A multiplied by the sine of angle B. And what we're going to have to do here is calculate sine of A and cos of B and cos of A and sine of B by going back and talking about the definitions of the sine of an angle. Well, the sine of an angle is the y coordinate over the value of r. Now, I'm going to go over here and talk about sine of B. Sine of B will be a y coordinate over an r value. The difference is, since angle A is in a different location than angle B, the y and r for angle A is not going to be the same as the y and r for angle B. So I'm just going to put a subscript on this and say that this y over r has to be for angle A, and this y over r has to be for angle B. And then we can do the same thing for cosine. We know that cosine is x over r, but we better make sure that it is the x and the r for angle B. And then over here we have cosine of angle A. We better make sure that's x over r for angle A. So what we need to do is find all of the x, y, and r values for angle A and for angle B. So we're going to take a little detour here. You're told that cosine of angle A is 5 over 13, and you're told it's in quadrant 4, I believe. I better check. Yes, it's in quadrant 4. So in quadrant 4, you know that x is positive, y will end up being negative, r, by the way, is always positive. Let's take a quick trip over and talk about angle B. You were told the tangent of angle B is equal to 4 over 3, but this was in quadrant 3. You know that in quadrant 3, x and y are both negative. Now, tangent of an angle is y over x. So if 4 over 3 is y over x, you might just think we can say y is 4 and x is 3. Well, we can't. We have to say that y is negative 4 and x is negative 3 because it's in quadrant 3, where x and y are both negative. We've run into this a number of times. You don't see the negatives in the tangent because when you divide negative y by negative x, you get positive for a result. Now what we need to do is use the Pythagorean theorem. In other words, x squared plus y squared equals r squared for both of these. I'll give everybody a minute here. Just pause the video, calculate the value of y in the left-hand column and calculate the value of r in the right-hand column. When you've got them, you can resume the video. All right, when I take 5 squared and add y squared and set it equal to 13 squared, when I solve that for y squared, I get y squared equals 144, which means y is plus or minus the square root of 144. Since this rotation angle A is in quadrant 4, it's the negative of the square root, which is negative 12. And then over here, when I take negative 3 squared for x plus negative 4 squared for y equals r squared, I'm going to get r squared equals 25, which means r is equal to 5. And that means we can use all of the x, y, and r values to fill in the information from our identity up here. Sine of a plus b will be equal to sine of a, which is the y coordinate of point A over the r coordinate, which is negative 12 over 13. And I'm just going to check. And that's correct. Multiplied by the cosine of angle B, which is the x over the r for angle B, which is negative 3 over 5. Plus x over r for angle A. We were actually told the cosine of angle A. It's right at the top in the question. It's 5 over 13. Multiplied by the sine of angle B. And the sine of angle B is y over r for angle B, which would be negative 4 over 5. And now it becomes a matter of us calculating what this is. You could, of course, use a calculator. I'm just going to do it in pieces. Negative 12 times negative 3 is positive 36 over 5 times 13, which is 65. Then I have plus 5 times 13 on the bottom is still 65. And on the top, I have 5 times negative 4, which is negative 20. And that means that it is 65 on the bottom and 36 minus 20 on the top. That tells us that it's exactly equal to 16 over 65. So 16 over 65 is our answer to the final example, example 4. That's the value of the sine of angle A plus B. Your assignment is attached. Complete 1A, 1B, 4B only, 5, 10, and 11 on the 2 pages that follow this lesson on the handout. You might have to go back and watch some of these parts of the video again and take a look at your notes as you go through this. I haven't been seeing a lot of you in Google Hangouts lately. I really hope that's because you're getting the math and you don't have any questions. Please do not be afraid to go into Google Hangouts so that I can talk to you and help you out if you need help. If you're uncomfortable with Google Hangouts or you don't have that technology, maybe your internet speed is not that fast, send me an email. I'd be happy to help you out however I can. Okay, so have a great rest of the day and we will talk with you soon.